This is an arithmetic sequence. An arithmetic sequence is just an arrangement or a set of numbers or a sequence of numbers going from one term to the next at a steady, even rate. So from 2 to 6, 6 to 10, 10 to 14, and so on and so forth. As we can see, we're going up 4 at a time, right? The way we think about terms is we see this as the first term. This is the first term. And we denote that as a sub 1. This is the second term. So we denote it by a sub 2. This second term is where the 2 is from. First term is where the 1 is from. As you can guess, the third term here is a sub 3. And so on and so forth. Our 14 will be a sub 4. Now that we know that, let's think about this pattern here. It's going up 4 at a time. What do we call that? Something is going up 4 at a time, no matter where. As you can see, the sequence goes up forever. So it's going to go 14, 18, 22, and so on and so forth. We call that the common difference. The common difference here, denoted by the letter D, is 4, because we're going up 4 at a time. All right. So you're thinking, wow, it should be pretty easy to find one term to the next, right? Just to find the fifth term, I'll just add 4 to 14, and that's okay. Well, what if you wanted to find a large number, say a of 50, or a of 100? You'd have to add 4 a lot, right? You have to do plus 4 to 18, then plus 4 to the 22, and so on and so forth. Well, the good thing about math is we can have formulas to make our life easier. Let's keep this in mind, the common difference of 4. Now, let's take a look at this formula, right? To find any term, a sub n, we do a of 1 plus the common difference times the term number n, not the term value, that's important. This n stands for the term number. A sub n is the term value, minus 1. All right. Now we're going to see why this works. Why does this formula work? In case you don't want to memorize it, maybe it's time we derive it. Let's think about it like this, right? We get, just numerically, right? How do we go from 2 to 6, right? So a of 2 will be a of 1 plus our difference. Let's take a look at our example here. We know 2, and our common difference is 4, plus 4 will give us 6, right? Same thing over here. We know 6 plus our common difference of 4 will give us our third term, 10, right? We can just write here, a sub 3 will be a sub 2 plus the common difference. So we're adding one thing before another. All right, so let's take a look at the algebra here, using the same example. If you excuse me here, I'll erase this. So we have a sub 2 equals a sub 1 plus our common difference. And a sub 3 follows the same pattern. Take the previous term plus add my difference. Now, since we know our algebra, we can combine it, right? I know what a sub 2 is, right? A sub 2 is a sub 1 plus d, right? So I'm just going to substitute it here. I'm going to write a3 again. a3 equals, and instead of writing a sub 2, I'm going to write what a sub 2 is. I'm going to write a sub 1 plus d plus, I'm bringing this d over here, right? All I'm doing is doing the algebra. So what does this become? This becomes a sub 3 equals a sub 1 plus d plus d is 2d, right? So as you could see, we have the third term here, and we're adding only two differences, right? If we followed the formula here, how would this work? Let's see if our formula would work in the same fashion, right? So I have, following the formula, a sub 3 will equal a sub 1, right, over here, plus d, and I'm looking at n minus 1, right? Our n here is 3, so I'm going to put 3 here, the term number minus 1. So I'm going to get a sub 3 equals a sub 1, 3 minus 1 is 2, 2 times 2 is 2d. As you can see, they match. That's why this formula works. Now let's take a look at an example. Let's keep this in mind. Let's keep this general formula in mind. Now let's try to find our a of 50. Let's try to find a of 50 using this formula. So I'm going to use a sub 1 plus the common difference n minus 1. So I'm just going to replace all the variables here. So I don't know what a50 is, so I'm just going to leave that as is. I'm solving for it. A1 in our example, this is our first term here. So I'm going to put 2 plus my difference here, as you can see, we have it up here, is 4. 4. My n here, remember, I'm looking for the value of the 50th term. Since I'm looking for the value of the 50th term, my n here is 50, right? Minus 1. So I'm going to get 2 plus 4 times 49. Now, 2 times 49 is 196. So this will be 2 plus 196, which is 198. That will be a sub 50. So that's how you can find any term using this formula. All right, now the way we describe this is that this is called the explicit formula. This here is called the explicit formula. This general way to find any term we call the explicit. The explicit formula just says I can find any term using an equation. That's what the explicit formula is. All right? So let's keep that in mind. All right. Now, let's try to think. It's another thing. Now you may get a question about finding the sum of a certain number of terms. Now, let's see the formula, because one thing nice about math, we can do formulas. And the same formula can be represented in different ways. So let's take a look at the sum formula. So the sum of a certain number of terms n, say the 6 terms, is equal to n divided by 2 times my first term, which over here would be a1 plus my difference of n minus 1. All right, so how can we do this? All we have to do is plug in the values, right? So let's find the sum of the first 6 terms, s of 6, for our example right here. all I'm gonna do is just replace the values that I have. Over here, it says n over 2. My n here is 6. 6 over 2. Parentheses 2 times my first term a1, which is 2, plus my difference here. Remember, my difference, I'm going up 4 at a time. Plus 4, n minus 1. My n here is 6. 6 minus 1. And I'm going to close my parentheses. So let's evaluate this. So 6 over 2 is 3. And 3 times 2 times 2 is 4. 4 over here. Plus 4. 6, 1 minus 1 is 5. So 4 times 5. You know, I know what 4 times 5 is. So I'll just replace it with 20. 20. Let's see if this works. All right, so I get over here 3 times 24, which is 72. So the sum of the first 6 terms is 72. Does this work? I don't know. Let's keep this in mind. Using our formula, we found the sum of the first 6 terms. So I'm going to keep that in mind. Now I want to show you why this works. All right, so I have, just keep the formula here. I'm just going to write here on the side, s of 6 equals 72, just for our reference, right? And that's what I'm looking for. S of 6 equals 72. All right, so let's add up the first 6 terms. First term we have is 2 plus 6, that's the second term, plus the third term, which is 10. Fourth term, which is 14. 14 plus 4 is 18, which is my fifth term, plus another 4 from 18, which is 22. So I have 6 terms in here total. All right, so let's add it all up. 2 plus 6 is 8. 10 plus 14 is 24. Right? 22 plus 30 is, 22 plus 18 is 40. So let's break this down. All right. So 8 plus 24 is 72. I'm sorry again. It's 32. I'm getting excited to show you that it's 72. 32 plus 40, which is 72, which is exactly the answer we got with the formula. So the formula, as you can see, works for any term, not just a small number, but like maybe sum of 6. It could work for sum of 100. All right. All right, so let's tackle a word problem you might see in real life. Gandalf is traveling across Middle-earth. The first day of travel, he is 8 miles away from Rivendell, the elf city. The second day, he travels an additional 12 miles. The third day, 24, and so on and so forth. So now the problem is asking to find the explicit formula, the recursive formula, how much he has traveled on the 12th day, and the sum of travels from day 1 through 20, right? Sum of travels, like how many miles he has traveled altogether from day 1 to 20. Let's take the tools we have learned to solve this problem. All right, let's keep it in mind, right? So, first day he travels. So my A1 is 8. Remember, he might travel 8 miles from Rivendell. My A2, then how much does he travel on the second day? Another 12 miles, right? So 12 plus 8 plus 12 will be how much? It will be, it says an additional 12. So 8 plus 12 will be 20 miles, right? On the third day, he travels 24 miles away from the 8 miles. So 24 plus 8 will be A3 equals 32. So as you can see, it is going up. You start at 8, you add 12, you add 12. So a common difference here is 12. All right. So our common difference here is 12. A1 is 8. Common difference here is 12. Now it's asking to find the explicit formula. Now the explicit formula looks just like a function. Remember, it's A of n equals A1 plus D n minus 1, right? That's the general formula. Now all I have to do is plug in to find the explicit formula, right? So we have to find any day Gandalf travels, A of n, we have A1. So what's my A1? 8. Plus, how much does he travel? What's the common difference? He travels around 12 miles a day. So 12 is the common difference, n minus 1. And I'm done. That is my explicit formula. It's that easy. All right. Now, let's take into account another question. Let's take a look on how to find the recursive formula. So the recursive formula is also kind of easy. The recursive formula, the way to find it, or the way to display it rather, is to say, I can find any term by using the previous term. I'll show you what I mean. All right, let's keep this in mind. Remember, A1 is 8. The common difference is 12. So to find the recursive formulas look something like this, right? They have some number A1. They say it equals something, right? And then they have A of n, right? To find any term n, remember what I said? I use the previous term. So what's before n, right? So what's before 5? It's 4. So how did I get from 5 to 4? I subtracted 1. So same thing here. The term before n is n minus 1, right? Term number n is n minus 1 plus our common difference. That's how recursive formulas generally look. All right, so all I'm going to do in here is plug in. So I'm going to say A of n, all right, equals A of n minus 1, right? This could stand for anything. And what's our common difference for this problem? It is 12, right? So it is 12. Right? So one thing I add on top of this to complete the recursive formula, remember I also have to add A of 1 somewhere. So I write A of 1 equals 8. And that's it. That's how that is my recursive formula. I say what A of 1 is, and then I show what A of n is. I can get to A of n from the term before A of n, which is A of n minus 1, and adding the common difference 12. So that's the recursive formula for this problem. All right. What else did the question ask? All right. How far did he travel on the 12th day? All right. So on the 12th day, how far did he travel? Again, we plug into the formula. Remember our explicit formula? Let's use that. It's easy. Our explicit formula says A of n equals A of 1 plus common difference of n minus 1. I'm just going to plug it in. We have 12 equals A of 1, which is 8. In our problem, 8 plus common difference, which is 12. I'm looking for the 12th day. The term number is 12. I'll put 12 in here. I get my minus 1 in here. So I get 8 plus, now 12 minus 1 is 11. So it's going to be 12 times 11, which I know is 132. So 8 plus 132 equals a of 12, which is 140. So he's traveling a lot on the 12th day, right? His first day he traveled 8 miles. Second day he traveled 20 miles. Third day 32. On the 12th day he traveled 140 miles. Now Gandalf is a wizard, so this is totally possible for him, right? And this isn't that bad, right? If you're going at 70 miles per hour, which you shouldn't do because that's very high unless the speed limit allows it. You know, it's just about 2 hours worth of travel. All right, so last question of the problem. It's asking how much did he travel from day 1 to 20? What's the total amount he traveled? Sum of travels day 1 through 20. All right, so I'm just going to follow the formula. So on my formula here, remember it's S of n equals n over 2 times a1 plus the common difference n minus 1, close parentheses, close parentheses. All I'm going to do is plug in. Remember, I'm looking travels, so of 20 days. So S of 20 equals n over 2, 20 over 2. Then I have 2 times, what's my a1, which is 8. My a1 is 8. Plus the common difference is 12. And what's my term number? 20. 20 minus 1, close parentheses, close parentheses. All right, now I'm going to evaluate using a different color. So S of 20 is 20 over 2 is 10. 2 times 8 is 16 plus 12 times, well, this is 19, right? 12 times 19, well, 12 times 20 is 240 minus another 12, which is 12 times 19, should be 228. 228. Wow, I might need a calculator for this one. And I don't have one. So I have 10, 16 plus 228. What's 228 plus 16? It's 244. 244. That's the sum of travels for 20 days. All right. Well, this is easy. It's just a times 10. Maybe I planned it that way. 10 times 244 is 2,440. So that's the sum of travels, the amount of miles he traveled in 20 days. All right, so that's how you find the explicit formula, the recursive formula, the term of any arithmetic sequence, and the sum.